Hello, this video is going to be a tutorial on creating an LSTM neural network that can predict tweets. You'll need another script for this video before we start, which is this tweetscrape.py, which scrapes tweets from the internet and puts them in a list from a certain user given a certain amount of tweets to scrape. I have another video on the channel. The first video is actually a tutorial on making this. This is a slightly modified version from the video. But yeah, so you'll need this. There will be a GitHub with this and the LSTM in the description that you can use. Yeah, hopefully this is a good video. This is going to be very hand-holdy. I'm going to be describing in pretty thorough detail, like every step. Like this is for you know how to program Python, but you've probably never done an LSTM before. And this might help you understand some of the things that you might need to do for an LSTM. And what else was I gonna say? I don't remember. I don't remember the other thing I was gonna say. So I'll just start showing you all the imports we need. So we're gonna need an embedding, LSTM, dropout, and dense from the layers. I'm just gonna do all the imports at the very beginning because that's how I prefer to do it. Okay, there we go. Here's all the imports. You may want to pause here and get all these down. And now I'm going to start. Okay. I'm going to create a function which takes in a username, a number of tweets to scrape, and a number to generate using the AI. And then I'm also going to do an if undername. Because that's my kind of style. I like to do that. I'll say username equals magic realism bot. This is the Twitter account that we're going to be doing AI tweets for. I like this one because it has a pretty consistent like pattern of tweets. So the predicted tweets from the AI are actually like not too bad. Num tweets. I'll set it to something like small, like 10, because I'm going to be running this a lot. But then later, when we're actually training the AI, I'll make it larger. And then we'll generate 10 tweets. So then we can say generate tweets. Okay. I'll just put a return 0 in here until we get like actual tweets to return. Okay, so the first thing that we're going to do is we're going to get tweets from the AI. I mean, not from the AI, from the scraping script. So we'll say tweets equals scrape tweets, username, and num tweets. So this is going to scrape 10 tweets from the Magic Realism Bot account. Then I'm going to create, or actually I'll show you what these look like. I'm going to do a lot of printing just to show you how things look, help you like better visualize what's going on. I know I should probably be doing this in you know, a collab or a I cannot remember the name of the other one right now. But I like doing these here. Did I spell it wrong? Oh, I said sequences. Okay, yeah. Pad sequences. There we go. Sorry, I had to fix that. Okay, so yeah, let's see what the tweets look like. Okay. They just look like this. Like it's just all you get from scrape tweets is a list of strings. Each string is a tweet from the user. Okay. So now we're gonna do a tokenizer. We're gonna tokenize a tweet, which basically means you represent every word in each tweet as a number, like an integer, because you can't really give words as an input to a neural network. That doesn't really work. So I'll say tokenizer equals tokenizer. I will set the filters to, this is just my personal preference. I want to filter out parentheses and quotation marks because I feel like those are usually don't work very well. So I like to leave them out. And then set lower equal to false. This basically just like if you didn't put this here, everything would be lowercase. It makes it a little easier to train, but I prefer it to capitalize correctly. And then we'll say tokenizer.fit on texts tweets, and then we'll say index equals tokenizer.word index. And then let's print out this and see what this looks like. The word index is a dictionary that contains each number that represents each word in your thing. So if we print this out, so yeah, the word A is the number 1, capital A is 2, is 3, in is 4. If I remember, yeah, it's the frequency of the word. Like the most frequent word is the first, the second frequent is the second, third. That's how it's tokenized. So that's the word index, and then we're going to need to do. Oh, first make a variable called vocablen. We'll use this later. But it's just the length of the word index plus 1, and we add 1 because later we're going to be masking zeros from the thing, and we need to add 1 to accommodate for that. Like the neural network's not going to recognize zeros as a word, because there's going to be padding with zeros. You'll see what that means a little bit more later. And I'll set tokenized tweets equal to tokenizer.text to sequences tweets, which converts every tweet in our tweets list into a list of integers that represent them. So show that really quick. Oops. My bad. Plus 1 goes on the outside there. Okay, yeah, so now instead of a list of strings, it's a list of lists, and each nested list is integers representing each word. So now we have turned our words into integers, so we're going to split them up. What I mean by that is we're going to turn, like, if we have like Bob drove down the street, that's going to become a series of lists. It's going to be Bob drove down the, like, word by word. You'll see why we do that later. It'll make sense. I'm just going to show you code right now. Make a list called split tweets. And then we're going to say for tokenized tweet and tokenized tweet. So we're going to loop through all of our tokenized tweets. Just bear with me for a second, then I'll explain what this kind of means. All right, I think that's correct. Let me print it out to make sure. I'll just print out the first 5. Okay, so yeah, you see how this one's 2, 13, 14, 15, 16, 17 right here. This one's 2, 13, 2, 13, 14, 2, 13, 14, 15, etc. until it creates the whole word, then it moves on to the next one. So I go from 1 to the length of the tokenized tweet. So like first, this starts at 1 plus 1, so it goes from 0 to 2. So we grab the first 2. Then it goes 2 plus 1, so from 0 to 3, so it grabs 3. Then 3 plus 1, so it grabs 4, up until the length of it, of the thing where it grabs the entire tweet, like tokenized. And the reason that we start with 2 and not 1 is because later we're going to split this up into a set of inputs and labels, and it's going to be that the last token of each of these is going to be a label, and everything else is going to be the input. So it's predicting the next word, and that wouldn't really work if it was just 1, like on the first one. It has to be 2. So there's the split tweets. Now we're going to pad them. So we're going to do pad sequences on the split tweets. And I'll do padding equals pre. Padding equals, so what this does is it finds the largest in the padded tweets. I mean, it finds the largest in the split tweets. And it makes every single tweet the same size as that one and just adds a bunch of zeros to the beginning of it because I set it to pre. You can also set it to post. It'll add zeros to the end. But I'll do pre for no particular reason. And then we create our set of inputs and labels. So inputs equals, we're going to do some really fancy slicing here. And the labels are the expected outputs for the network. To categorical. Oops. And we're going to set the number of classes in the categorical to the length of the vocab. So yeah, this takes every word up to the up to the last one. So like if we were doing this one, for example, the input for this thing would be 2, 13, 14. The label would be 15. I'll print that out and show it to you. Okay. Okay. So here is our input. So as you can see, it's padded. So there's a bunch of zeros in the front. And the one we're looking at right now is the 2, 13, 14, 15. So the input is the 2, 13, 14. And then on the output, the 15th zero is turned to a 1 because we converted the output to a categorical because it's the kind of output we need for this. So that's what that looks like. And now I think that we move on to making the model. Yeah, okay. So I'll say sequence len equals the length of the first input. This variable just represents the length of any of the inputs to the network. We use that a couple times later. Okay, now we're going to create a sequential model. Okay, so our first thing is going to be an embedding layer. This represents like each of the numbers in our thing as a matrix, and it trains that. I believe that it actually trains the values of this matrix to make to like represent semantic relationships between words. That's kind of a terrible explanation, but I'm pretty sure that's what it does. But it has to change it because the issue with leaving the inputs like this is that like 13 and 14 would create similar outputs even though they have no semantic, they could have no semantic relationship or very little. And we don't want that. So we create an embedding layer. We set the input dim to the vocab len. Output dim. This is the size of the embedding layer. I put mine at 100. You can do yours whatever you want. I mean within reason, but 100 works. Length. Input length is the sequence length. So that's just, the size of every input. And then mask 0, we're going to set to true. So it's going to ignore all the zeros because that's what we use for padding. Okay, then we're going to add an LSTM layer. And I'm going to give it 125 nodes. Oops. Then we're going to add a dropout. I like 0.15. And if you don't know what a dropout does, which hopefully you should, it randomly turns the value of nodes in the previous layer to 0 based on the probability you provide. That helps avoid overfitting, which is a big problem in LSTMs. And then a dense layer for the output. So vocab length, and we're going to set the activation to softmax and the loss to categorical cross entropy because this is still a classification network. So that's what we would use for that. Like it's a kind of weird one. Like it doesn't classify in the way that like you'd classify images. I mean it does, but it doesn't seem like it would. But yeah, that's what it is. It's just classifying, what word goes next. So now we're going to compile the model. I'm going to say, yeah. Categorical cross entropy. Set the optimizer to Atom because everyone uses it. I don't really know. I don't know if there would be a better optimizer for this situation. Atom has worked fine for me. And then I'll add accuracy as a metric because I like the accuracy. Oops. Okay. Now we will fit the model to our inputs and our labels. Give it 30 epochs and set the batch size to 32. And a lot of this stuff, like batch size 32, dropout 0.15, LCM 125, that's stuff that you can experiment with and change. It's not like set in stone that that's the best stuff. In fact, it's very most likely not. But that's just what I've gotten that works, like based on my own experimentation. So yeah, like all this, it's just like heuristic stuff. You just kind of have to know the range that you should do it in, and then test out a bunch of different things to see what works best for your particular situation. Okay. Now let's give this a shot, make sure it works. It's not gonna show anything here, but we should see it. Got multiply story. Oh crap, the optimizer is the first thing, isn't it? Yeah, okay, yeah. This is, I have to set this equal to loss. Okay, now it's successfully running. Okay, yeah. And it was really fast because we're only scraping 10 tweets. All right, that all works. Now we're gonna have to get this model to actually predict outputs for us. So this is, you can do this in a number of different ways, but I'll show you the way I did it. Okay, now I'm gonna start just writing this code, and I'll have you copy it. I'll explain it in just a second. So this is a list of all of the lengths of every tweet in our scraped tweets, and then we're gonna find the standard deviation of the lengths and the mean. Right, is that correct? Yeah. And then I'm gonna initialize an empty list for our tweets that we generate. Okay. So the reason that I do this is that you have to give it, the network generates word by word. So you give it a seed word or a certain amount of seed words, and it'll generate the next word based on those. So if you start with 2, it'll generate a third word. Then you put all 3 of those back in, it generates a fourth word. But you have to specify how many times you want it to do that. And the way I do it is I get the mean and the standard deviation of the lengths of all the tweets from the actual user, and I use that to find a random number for the length of the tweet, like when we generate it. So it kind of looks like a length that they would do, but it varies. That's just a method I came up with doing. You could do a number of other things. If you wanted a simpler one, you could just find the average length of every tweet and then make that like all of your generated tweets. That would also work. Yeah, okay, let's start generating now. So we'll say while the length of generated tweets is less than the number to generate, we're going to start generating. Okay, so the way that I do this is I get an actual tweet and I take the first 2 words from it, and those are the seed words for the network. And the reason I take the first 2 is because the network is deterministic, and if the first word is like A, if you get that multiple times, which could be likely, then it'll generate the same thing for all those, and I don't want that. So I'm getting the first 2. So I'll say random first tweet equals choice. This is random choice from tweets. And then if the length of that tweet, oh yeah, I have to split it. Make it into a list of like each word by splitting it by space. And then I'll say if that's greater than 1 length, so there's 2 words that I can actually get from it, then I'm gonna say first words equals random first tweet of 0, so the first word, and random first tweet of 1, so the second word. So we get the 2 first words from this actual tweet. And then word list, this is going to be what we use to input to the network, is going to be a list containing this list of first words. And we need to contain this in a list because that's what the inputs of the network have to look like. It has to be nested list. Okay, now I'm going to get a number of words for the tweet. So tweet word count equals, well, I think it's, okay, so we're going to use random normal from NumPy. I'm going to set LOC to the standard deviation, mean, and then scale to the standard deviation. And then size equals 1. And okay, so this makes us a random number using our standard deviation and mean. And we're going to round this to make it an integer because we need an integer. Okay, yeah, and this is this is going to be the length of our tweet. So now we're going to say while the length of the word list of 0, and the word list is what we're generating. We're going to keep generating using this word list. So while the length of that is less than tweet word count, we're going to start predicting words for it. Now we're going to actually start using network. So this is going to be kind of a long line. The input is going to be text to sequences word list of 0. So we're going to make this, we're going to tokenize our word list, and then we're also going to pad sequences it and set the max length to sequence len. Is that correct? Yeah, and then also the padding to pre. Okay, so now we've got a padded and tokenized input, so we're going to generate a prediction from the model. So now we have a prediction, but this prediction is right now in the form of a categorical, like it looks like this, and we have to get a word out of that. So we're gonna say new tokenized word equals argmax of our prediction, and this gives us, it just basically finds the 1 wherever that is, or it finds the, it's not really going to be 1, it's going to be like a one, it's going to be a bunch of numbers between 0 and 1, and one of them is going to be the largest. It's going to find that one, and if that's at like 16th position, it's just going to be 16. So this is our tokenized word, and we're going to convert this to a word, and this is also going to be kind of a silly line, which I will write and then explain. Okay, so this converts, I don't know why this isn't highlighting. Did I do something wrong? That's weird. Okay, I guess we'll see later, but basically what this does is, oh no, I have done something wrong. Sorry, I had a misplaced parenthesis. And it's still not highlighting. That's so weird. No, whatever, it's probably fine. So this takes our tokenized word, and I convert all the values of our word index. And if you remember, our word index is, where did I print it? Here. Where each key is a word, and the value corresponding to that key is the integer that the word that represents the word. So we make a list of the values, which are our tokens, and we find the index of our word, like our tokenized word there. So if we got 48, we go to 48 on this, we find the index of it in the list, and then we use that to find it in our keys, which we also convert to a list. So this just basically, we take a tokenized word, we convert it to whatever like actual word it represents in English. So, you know, if we got 46 here, we'd get the word judge. And then we add our new word to our word list. So we're going to say word list of 0.append new word. Why am I not getting syntax highlighting? This is weird. I feel like I've made a weird mistake somewhere. But I guess we'll see when we run it. So yeah, we append the new word, and then it's going to keep repeating this process, predicting new words and adding it to the word list until it's long enough. And then after we escape this while loop, we are going to say that the actual tweet equals, we're going to join our word list into a single string, because right now it's just a list of words, and then we're going to append it to generated tweets. And then finally at the very end, we return generated tweets. I don't know what the deal is with this not highlighting right now, but let's go ahead and run it. This should work theoretically. Oh crap. Okay. Ugh, I do this all the time. Generated. because generate tweets is the function that we use to generate the tweets. Is this okay? Try it again. Come on. Okay. Okay, there we go. It seems to have worked, although I forgot to print the output. Oops. So we'll say, let's just say that, and then give it more tweets to scrape. Give it like 300. I think that's probably a solid amount. And run it one more time. Let's see if it works. It's for, we're going through each tweet, not all of the tweets right here in this length. Let's give that another shot. Holy crap. Okay, I've done it again. I've appended the entire list of scraped tweets to generated tweets instead of the individual tweet that we just generated. I gotta start naming my variables better. These are really messing with me. I have made another mistake. In this text to sequences, it actually does take the whole thing, not just the nested list. So I will try again. Okay, I restarted VS Code and I got my syntax highlighting back. And I ran it and I got these. I think these are relatively good results. A flamingo in Borneo was born in the North Pole. Like the tweets from the Magic Realism bot account basically are like AI generated short like story prompts, I guess you could say. So some of these look kind of like that. Try it with one other account. Let's do Kanye West. And actually, I'm gonna up the number of epochs a little bit, just like 35. Okay, and here we go. Here are 5 Kanye West AI generated tweets. Yeah, so I hope you enjoyed the tutorial. This functions. I think it's pretty neat. I think it's a cool concept, and I hope it kind of helped you understand how you might go about pre-processing for, you know, like natural language inputs to a neural network and getting results from that. And this is, if you've seen the video I did on the app, the tweet generation like AI app, this is a slightly like a scaled down version of that. There's a few other features that I had in that one, like an early stop callback for a certain time, and I used pre-trained word embeddings on that one, and a little bit more error handling so that things don't like go wrong and crash the whole server. But yeah, this is that. If you have any questions, make sure to do them in the comments, and I'll try to respond to them. I hope that my explanations are pretty good. I know this video was a little bit weird. I tried to do it in one take. But I hope it helped you, and thank you for watching.